A previous module introduced behavior-driven development, in which user stories in plain English, combined with low-fidelity user interface mockups, could be turned into high-level cucumber scenarios that serve as both integration tests and user acceptance tests. Scenarios are great because they exercise your whole app, and they stimulate it in the same ways that real users would. That makes them pretty realistic as test cases. But they're not very thorough. The simple scenario we introduced in the previous module's intro video, in which a user added a new movie to Rotten Potatoes, is what we call the happy path. It describes what happens when the app is working correctly and the user does everything exactly as we expect. But we all know that in real life, all kinds of things can go wrong, whether because of bugs or because the user behaves differently than we expect. Even in the simple example of adding a movie to Rotten Potatoes, what would happen if the user left some required fields blank when submitting movie details? Or if they tried to create a movie that already existed in the database? Surely we don't need to create a full scenario for every different sad path, do we? And even if we did, how would we know if we had covered all the cases? In this module, we'll take a deeper dive into testing by creating unit tests, which test a single method in a single class, and module tests, which test a behavior that involves several methods, possibly in multiple classes, but still smaller in scope than a complete trip through the app like a scenario. We'll use RSpec, which you've already seen in passing in some of the programming assignments, to create these tests. Unit and module tests are complementary to scenarios in that you can't rely on just one type of test. As we'll see, unit tests can run very quickly and can explore code paths that are awkward to reach with scenarios, but they artificially isolate the components under test from the rest of the system, so they don't really test the interfaces or connections between components. In contrast, scenarios exercise code across module and class boundaries, but they're much more heavyweight, so they run more slowly, and they cannot always illuminate the dark corners of your code like unit tests can. Similar to how you can write scenarios before your code is written, the practice of test-driven development, or TDD, advocates writing unit tests before you write the code so that the test will drive the development of the code just as with BDD. As we'll see throughout the rest of the course, a less obvious but critically important benefit of test-driven development is that writing tests makes you think about how the code you're about to write will be called, and that leads to better structured code. In other words, testable code tends to be good because good code is readily testable. Because unit and module tests are intended to test a method or a small set of methods in isolation, you'll learn how to create and use test doubles to decouple the behavior of the methods being tested from the behavior of other methods they may depend on. You'll also learn that determining how much of your app is covered by tests is trickier than it might seem. So, like all other metrics, you'll learn to measure different kinds of test coverage, but take the numbers with a grain of salt and with good engineering judgment. Getting good coverage with a combination of scenarios, unit tests, and module tests will give you confidence not only that your app will behave correctly when users don't behave as you expect, but also that as you evolve and change your app in the future, you'll know immediately if you broke anything because one of your tests will fail. This safety blanket will be especially useful when modifying code you didn't write, as we'll explore later in the module on legacy code.